Good afternoon. Am I audible?
Yes, ma'am.
Okay. So in last lecture, am I audible properly?
Yes, ma'am.
Okay. Okay, thank you. Chalo, so in last lecture, we have seen Fourier transform and inverse Fourier transform, right? So now we'll go ahead and we'll see the last topic in this unit, that is Fourier sine transform and cosine transform and its inverses. So give the heading. Fourier sine and cosine transforms and its inverse. So we'll first write Fourier sine transform. Fourier sine transform. Okay, so its name again indicate there should be sine terms only. And what will be the definition? Okay, what was the definition of Fourier transform? Can you just tell me? F of s is equal to Fourier transform. I'm asking Fourier transform. 1 upon root 2 pi, right? Integration,
from minus infinity to infinity.
right?
F of x
x
e raised to isx dx.
e raised to isx dx. But that e raised to isx I can write as cos sx plus I sin sx into dx. Is it okay? E raised to I theta?
Yes.
Right.
Yes.
It is cos theta plus I sin theta. So I'm writing e raised to isx as cos sx plus I sin sx. And then if I say that your function f of x is even in this, okay? So if we'll open this into this, and integration will separate this into this, right? So if this into this, if function is even, cos is also even into even, right? And if function is say odd and even into, sine is, how is sine function?
Odd.
Odd. Even into odd will be
Odd.
odd, and integration of that sine f into sine, that part will be
0.
0, right? So only this will be f of x into cos sx dx. And this minus infinity to infinity for the even function will becomes 2 times
2 times 0 to infinity.
0 to infinity. Very good. So in this, if you see, then function if is even, then there is into the term cos. Means that will be which transform then? Cosine.
Cosine.
Right? So what will be the definition of cosine transform? Because the second integral is directly 0. We'll see that cosine. We have written sine first. So we'll think about this. So if your function is say odd, cos is even. So odd into even, odd. And integral this is then 0, right? The second integral remains. So odd into odd, that will be even, and it will return. So the definition of the Fourier transform, the first thing is notation. We have used f of s for Fourier transform, and for Fourier sine transform we write FSS. This is the subscript. Fs denote Fourier sine transform. Okay, so it is defined as, let me just tell you here, it is 2 times 0 to infinity, whatever it is 2 times 0 to infinity upon root 2 pi, right? Minus infinity to infinity becomes 2 times 0 to infinity. But that 2 is nothing but root 2 into root 2. So here 1 root 2 will get cancelled. And what will remain? Root 2 by
Root 2 by pi.
right. So this is root 2 by pi. Integration limits are
0 to
0
infinity.
to infinity, correct? F of x into, for sine transform, sine sx
Sine.
dx. Done. This is the definition of Fourier sine transform. Here, but function need not to be even or odd. Okay, I just tell you the example. This happens like this, but it can be defined to any function. This is the definition of Fourier sine transform. Please note it down. No need to write this. So can you now tell me what will be the Fourier cosine transform? Can anyone tell me what will be the Fourier cosine transform?
Cos sec instead of sine.
Right. Sine will only replaced by cos sx. That's it. And that will be the Fourier cosine transform. Chalo, we'll see one question on this and then we'll go to the cosine and inverse later. So write the question. Find the Fourier sine transform of. Find the Fourier sine transform of f of x is equal to 1 in 0 to 1 and 0 when x is greater than 1. First thing is the question, you have to read it with atmosphere, like what is asked. Is it series? Is it transform? Is it sine? Is it cosine? Or is it just the integral? So what is asked here?
Fourier sine transform.
Fourier sine transform, not just Fourier transform, Fourier sine transform, right? So we know, right, the definition, Fourier sine transform. A short form you can write FST, Fourier sine transform. And is defined as FSS is equal to root 2 by pi. Integration is 0 to infinity f of x into sine sx dx. Okay, now we have to write the function. What is the function? What is the value of the function and what is the interval?
1 between 0 to 1.
Right. In 0 to infinity, you are writing. The given thing is 0 to 1 and 1 to infinity. But whenever it is 1 to infinity, the value is directly 0. So no need to take this. We have integration 0 to 1 and the corresponding function is 1. So it is root 2 by pi. Integration is from 0 to 1. Function is 1 into sine sx dx. So you have to solve this integration. What is integration of sine?
Minus cos.
Right. So it is root 2 by pi integration sine sx dx is there, which is minus cos sx
Upon yes.
Upon x.
upon x or s. S
S.
or x.
S.
S. Is this correct? Because it is with respect to x, so the constant is s. So upon s. And from 0 to 1. And you are writing the upper lower limits for what?
For
X.
x.
X, right? So x is first 1 you are writing. So minus cos s upon s as 1. And then lower limit, then there will be the negative sign. Negative of negative will become positive. X you are writing 0. So cos 0, 0 into anything 0 upon s. Okay, so it is root 2 by pi. What is cos 0?
1.
1 minus cos s as it is, and the denominator is same, so you can write it together. So yes, this is your required Fourier sine transform. There. So such things can be in MCQ. Isn't it easy? Just a formula. If there is 1, 2, some numbers, you can just put there and solve the integration. Simpler integrations can be asked. Any doubt here?
No.
No.
Good. Can we go to next question?
Yes,
Yes.
ma'am.
Right. Read the question. Find the Fourier sine transform. Same question again. Find the Fourier sine transform of f of x is equal to sine kx in 0 to a, 0 less equal x less equal a, and 0 when x is greater than a. Okay, once again, it is the Fourier, not series, not just transform, but the Fourier sine transform, and is defined as FSS is root 2 by pi integration 0 to infinity f of x sine sx dx. So here it is root 2 by pi as it is. We have to write the function, and the function is this, out of which one is directly 0. So we are not taking it into consideration. The value is this on this interval. That is, function is from 0 to a. So integration limits are also from 0 to a. And for this f of x, what you can write?
Sine.
K.
Right, sine kx. Sine kx into sine sx dx. Good. So now we have to solve the integration, but there are two signs together. Can you solve directly?
No.
No. Can we apply Leibniz?
No.
No. Why we cannot apply Leibniz?
Because derivative of not anyone will be zero.
Right, because derivative of none of the function here is 0. Good. So yes, we have to solve this, but so we cannot apply Leibniz, we cannot directly solve UV integration. UV will also not be applicable in this case. So what is the way out?
2 sine sine.
Good. So there should be 2 multiply, and as multiply you should also divide.
Divide.
Right. So that 2 will come out 1 by 2, root 2 by pi as it is, and integration as it is 2 sine A sine B. We need this formula 2 sine A sine B. What is that? 2ss.
Cos A minus B minus cos A plus B.
Right. Minus CC
Yes.
minus
Yes.
cos A plus B plus cos A minus B. So it is 2 is utilized here for 2 sine A cos B, 2 sine A sine B. 1 upon 2 is out. That is minus cos A plus B, kx plus sx. X is common, so k plus sx plus cos A minus B, kx minus sx, k minus sx dx. Is this correct?
Yes.
Right. So now integration can separate with this addition. So we'll just separate it and solve. Here it is root 2 root 2. Root 2 by root pi, and this 2 can be written as root 2 into root 2. So 1 root 2 get cancelled here. And now we are integrating. What is integration of cos?
Sine.
Sine plus sine, no, minus sine
Plus.
plus
Sine.
sine. So negative sign as it is, integration of cos is sine k plus s x upon what?
K plus S.
K plus s. Very good. Derivative of this term with respect to x. This is the constant and will come down. So plus as it is, again integration of cos is sine k minus sx upon k minus s. But this is from 0 to a. So here is 1 upon root 2 pi, I guess.
Yes.
Right. So it is 1 upon root 2 pi. So root 2 and root pi together. Okay. So upper limit you are writing x as a. So this is minus sine k plus sa. Minus sine k plus s a upon k plus s. Okay, next term. Here also you are writing upper limit a. So plus sine k minus sa. Plus sine k minus s into a upon k minus s. Okay, upper limit done. We have
Yes.
written a there. Now lower limit is 0. So for this x we have to write 0. 0 into anything 0, and sine 0 is,
0.
so this is 0. This is also 0. If x is 0, sine 0. So both the lower limits are 0. Okay, so your answer is this one. Done. It is like 1 upon root 2 pi sine positive, I'll write first, sine k minus sa upon k minus s minus sine k plus sa upon k plus s. Done. This is the required Fourier sine transform. But just check everything is in S. There should not be X finally. It should have removed. Any doubt?
No, ma'am.
Chalo, you will solve this now. Find the Fourier sine transform of similar question. Find the Fourier sine transform of f of x is equal to 0 in 0 to a, x in a to b, and 0 when x is greater than b. Chalo, write the Fourier sine transform definition first. Try to solve. FSS root 2 by pi 0 to infinity f of x sin sx dx. You should always remember the definitions. They can directly be asked in MCQs. What is Fourier sine transform? So accordingly, you have to choose the correct definition. So this one is correct. Chalo, we'll put the function. Function is
X.
x. Very good. All the remaining are 0. No need to consider. And this x is in on the interval
A to B.
a to b. So a to b x sin sx dx. Now you need to solve this integration. Just think, check your time and tell me how will you solve this integration.
Leibniz rule.
Yes, can we apply Leibniz rule?
Yeah.
Yes,
Everyone is getting?
yes, ma'am.
Because this derivative of x will be 0. So this is your u and this is v. So just solve it. Root 2 by pi u v1 integration. U as it is, v1 means first integration. What is the integration of sine?
Minus cos.
Minus
Right,
cos.
minus cos sx upon
Yes,
s. Is this correct? S?
yes, ma'am.
Right, because it is with respect to x, so s is constant. It will come down. Then there is the sign
Minus
minus. Derivative of this
1.
1. Integration of this.
Minus sin sx
Right,
upon
minus sign as it is. Integration of cos is sine. Sin sx upon s. But there is already one s. So s into s, s square. And next derivative of this will be 0. So yes, this is over, and from a to b. So for x, everywhere you will first write b, and then negative sign will give, and for x, everywhere you will write a. Do that. I'll try to write it here. Root 2 by pi. Upper limit is b, so all the x are now b, so it is minus b cos sb upon s, minus minus plus sine sb upon s, upper limit done, minus lower limit x is now a, so minus a cos sa upon s, minus minus plus sine sa upon s square. Yes. So if you want finally, you can write it minus minus plus, plus minus minus, and that will be the answer. Next question. Same question. Second in that, find the Fourier sine transform of f of x is e raised to minus x by 2. Chalo, start solving. You are solving Fourier sine transform. FSS. Root 2 by pi. 0 to infinity. F of x sin sx dx. Okay, so it is root 2 by pi. What is the function?
E raised to minus x by 2.
Right. And what is the interval?
0 to infinity.
Right. As it is not defined, so it is whatever is the original, 0 to infinity. Now you have to solve this integration. No Leibniz. Yes, because none of the functions derivative is 0 here. And I guess we have something for this. Do you remember?
Yes.
Right. Two definitions are there for such. This is standard one. We have integration e raised to ax cos bx dx and integration e raised to ax sin bx dx. Okay, what is this?
A square plus b square.
X upon a square plus b square.
Right, into,
A cos bx
right,
plus
Sin
b sin dx.
plus b sin bx. Correct. If it is for cos, there is plus in between. Same term here, e raised to ax upon a square b square. We start with a here, whatever is here, multiply to that, a sin bx. And for sine, there is
Minus.
right. A becomes b, sine becomes cos. Okay, so this is two formulae we know. So which one we are going to use? The second one. Right. So we have, if we compare, what is A?
Minus 1 by 2.
Right, minus half. And what is B?
Is
S. Right. So we are applying for this. Let me take it forward. Root 2 by pi. E raised to minus x by 2 sin sx dx 0 to infinity. Okay, so it is e raised to ax upon a square. A is minus half. So minus half square plus b square. B is s. Into a is minus half, into sine a sin sx, minus, as it is sine there is minus, b is s, sine becomes cos sx. and the whole is from 0 to infinity. Have I written it correctly? Just check once. E raised to ax as it is upon a square, yes, plus b square, a into sine minus b into cos, correct. Okay, so if it is the upper limit infinity, what will be this term?
0.
Right, correct. E raised to minus infinity by 2. Infinity by 2 is again infinity. So e raised to minus infinity we have seen so many times. It is 1 upon infinity. That is 0. And 0 upon anything and 0 into anything, the term is 0. For upper limit, the whole thing is 0. Minus lower limit now. X, you are writing 0. So e raised to 0 is
1.
1. So this is 1 upon minus square is plus 1 by 4 plus s square into, here if it is 0, minus half into sine 0, I'll write it as e raised to 0. Let it be e raised to 0 upon minus half into sine 0 minus s into cos 0. And here also I'll write e raised to minus infinity if you want into anything. So this is 0. So that's why it is 0. You can directly write. No need to write anything. Chalo, write it directly 0. So you're solving now root 2 by pi into e raised to 0 is
1.
1. So minus is there 1 upon, just cross multiply this, 4a square plus 1. So 1 plus 4a square whole upon 4
4.
into sine 0 is
0.
0. So 0 into anything, this is 0 minus s cos 0 is
1.
1. So this is just minus s. And then a upon b upon c, 4 will go
Numerator.
numerator, correct. Minus minus becomes plus 4s upon 4s square plus 1. Done. This is your answer. And every time you are checking that, there shouldn't be any x finally. Is it okay about Fourier sine transform?
Yes.
Good. Chalo, we'll see now the inverse Fourier sine transform. Give the heading. Inverse Fourier sine transform. Okay, if you remember what is the inverse Fourier transform, you can easily now tell me the inverse Fourier sine transform. For that, for your reference, I'll write the definition of Fourier sine transform. Okay, so you can tell me inverse Fourier. Root 2 by pi integration 0 to infinity f of x into sine sx dx was Fourier sine transform. Now we need this definition, inverse Fourier sine transform. Chalo, tell me the definition now. Role reverse. So here it is f of x is equal to, as it is, root 2 by pi, 0 to infinity, fss into sine sx into
DS.
yes, very good, ds. If you are taking its inverse, means you are converting back to x. So you should integrate with respect to s. Please remember, function is of variable s, so there should be s. Very good. So write the definition. You can write this directly. This is the definition of inverse Fourier sine transform. Done?
Yes.
Sure. Write the question. Find the Fourier sine transform of e raised to minus x, where x is greater or equal 0, and hence deduce that integration 0 to infinity x sine mx upon 1 plus x square dx is equal to pi by 2 e raised to minus m, m is greater than 0. Read the question carefully first. Find the Fourier sine transform of some function and hence deduce. I told you, what are the hence deduce part generally?
Inverse.
Inverse. Very good. So inverse part is there. Whatever is x, that should be what then?
S.
S. Very good. They have changed it finally. And m. What is this m should be? Because if we take inverse transform, it get converted to the function, back to the function f of x. So this should be originally x, and they have changed, might have changed the variable x by m. We'll see. Chalo. So first, straightforward we'll go. Find the Fourier sine transform of. So let us call this function as f of x. Because they haven't called it as, so we'll write it as function f of x. It is defined from x is greater or equal 0. And now we'll write Fourier sine transform. FSS. Root 2 by pi, 0 to infinity, f of x into
Sine
sine sx d
X.
x, because it is so sine transform, not the inverse. Sure. Put the values. Root 2 by pi. Okay. Function is e raised to minus x into sine sx dx. What are the limits?
0
0
to
Right. It starts with 0 and goes up to infinity. Starts from 0 to up to infinity. Okay. We have to solve this. Which formula? Which you have just seen now. E raised to ax sine bx dx. So it is root 2 by pi. E raised to ax upon, what is a?
-1.
Right, minus 1 square plus b square. B is
S.
Yes.
s. Decide your b. Because as it is with respect to x, s is constant and it is your b. Into a square plus b square into a. A is -1 into sine. For this sign, negative in between. Minus b. B is s. Sine becomes cos sx. And this is from 0 to infinity. Okay, if it is the upper limit infinity, what will be the upper limit?
0.
Good. As if you put it is as infinity e raised to minus infinity, that will be 0. So yeah, 0 upon anything and 0 into anything, the whole term becomes 0. Minus lower limit. You are writing x as 0. E raised to 0, 1 upon 1 plus s square. 1 square is 1 into sine 0, 0, 0 into anything 0, minus s into cos 0, cos 0 is 1. Yes. And this minus minus will be plus s upon s square plus 1 into root 2 by pi. Correct? Instead, I'll write 1 plus s square by looking to or show that. S upon 1 plus s square plus 1 or 1 plus s square. Can you see it there? And hence deduce that s upon 1 plus s square. Yes, it is there. They have changed it by x finally. Okay, so now we have FSS. We can use the inverse Fourier sine transform. Because we have used Fourier sine transform, so we'll use inverse of Fourier sine transform itself. What is the definition? F of x is equal to root 2 by pi, integration,
from 0 to infinity.
correct?
F of s
FSS,
sin x is ds.
sin sx you can say or xs you can say. हे एकच आहे sin sx
S.
ds. Okay, so we have FSS, write it there, root 2 by pi, 0 to infinity, right? FSS we have, write it there, root 2 by pi, s upon 1 plus s square, sin sx ds. Okay, these two get multiplies, root 2, 2, root pi, pi, and comes out. Integration 0 to infinity, s sin xs upon 1 plus s square ds. Do we need to solve this? No,
No.
that is your evaluate part, right? So if you can see, we can change s by x in the final step. S will be x later, but what will be that x first? Just see. We need sine mx, means it is, we are replacing x, s by x, this is your s, so there should be sine ms. Sine ms, so what should we write for x?
M.
M. So put x is equal to m and take this here also, pi by 2 comes here into f of m is integration 0 to infinity s into sine x is now m ms upon 1 plus s square ds. But we have to write now f of m. We have the function. See what is your f of m. F of x is this, e raised to minus x. So x will replace by m then. It will be e raised to minus m. Correct. Okay, so I'll go here. Pi by 2 into, but f of m is e raised to minus m. So pi by 2 into e raised to minus m is equal to integration as it is. 0 to infinity s sine ms upon 1 plus s square ds. But there is no s, there is x. So now, yes, we can change the variable s by x inside the integration. So replace s by x. All s we are writing x, baki sab as it is. So it is integration 0 to infinity x sine mx upon 1 plus x square dx. All x, so it should also get changed. So what is the value? The value is this. The evaluate question. So the value of the integral is, no, it was show that I think. Yes, it was deduction. So we got this pi by 2 e raised to minus. Yes. Any doubt?
No.
Good. Sure. We'll see one more question. Do you have something to ask? Please ask. Huh? Find f of x if its Fourier sine transform is, if its Fourier sine transform is e raised to minus as. Read the question carefully. Find f of x if its Fourier sine transform is given to you. Means what is given? F?
F of x.
No. Find f of x. You have to find this. And if
FS.
it's right, Fourier sine transform is given to you. FSS is e raised to minus as is given. And it is asked to find f of x if it is having FSS. What you can use? You need f of x. You have this.
Inverse Fourier sine transform.
Right. If you want the function, you should use inverse. And if you want Fourier transform, you should use the definition f of s. But this we have, means you should use inverse. So by inverse Fourier sine transform, what do we get? F of x. Root 2 by pi. Integration 0 to infinity. FSS into, come on, into
Sine x's.
sin sx, correct. D
ds.
S. Right, FSS, root 2 by pi. Integration 0 to infinity. E raised to minus as sin sx ds. Which formula you are going to use now? E raised to ax cos, no, e raised to ax sin bx dx. Chalo, try. I want you to try this step. Please try. What is A? What is A here? E raised
Minus
to ax. Right. Here A is minus A. And what is B?
x.
Think once again. All of you. What is B? You're comparing e raised to ax sin bx dx.
Yes.
Okay, S.
X.
Okay, X. X or S.
X.
Now,
X.
okay. Now, because this integration is not with respect to X, this is with respect to S, means e raised to as sin bs ds it is. So now you can tell me A and B. E raised to as, A is minus A, sin bs. So B should be
X.
X. ds. Variable matters. So as it is with respect to S, S is the variable and constant is X. That's why I used to write it as sin XS so that you can understand X is that B. Are you getting?
Yes, ma'am.
Good.
Yes.
So B is X in this case. So it becomes then root 2 by pi e raised to as upon a square, a is minus a square plus b square, b is x, into a is minus a, into sine sx, minus b is x, into cos sx. And this is from 0 to infinity. Now you are writing the limits for what?
S.
S. because the integration is with respect to s and not x, right? So you are writing the limits for s. So yes, if you put upper limit infinity, what will be the value here?
0.
0. Very good. E raised to minus infinity. So this is root 2 by pi, 0 into anything 0. Minus lower limit if you are writing s as 0. E raised to 0, 1. Minus square, a square plus x square into sine 0, 0. Minus a into 0. Okay, this is 0. Okay, cos 0, 1. Minus x into 1, so minus x. This minus minus becomes plus, so your answer is root 2 by pi x upon x square plus a square. Is that correct?
Yes.
Good. Any doubt? Find f of x means it should be in x, it should not be in s. So yes, it is in x. And to convert back into x, we know you should use inverse transforms. Okay, so I guess this is all for today. Let me take attendance. Only a small topic is left, that is Fourier cosine and inverse Fourier cosine. And then we will be completing our syllabus. But for DSY, we have one more unit, Fourier series. We'll complete it soon. Give me a minute, do not leave. Okay, as we are completing our syllabus, so I think we should start solving the MCQs. We'll discuss the MCQs, we'll start solving them. But we have 1 or 2 more lectures to complete, then we'll decide. Okay, this is all from my side. If you want to say something, go ahead, we have time. Nothing? Sure, we'll stop then.